Great. Well, hello, everybody. It was great to hear several familiar voices during that roll call. So this should be a really fun hour, and hopefully I'll share some information with you guys that you'll find interesting. So I'll start out going through my slides, I suppose, and if anybody has a question, feel free to jump in at any time. All I ask is that please identify yourself when you ask your question. So on slide number 2, the overview of the company, you guys probably all know this already, but we've been around since 2002, and the goal of the company, really, Elon founded the company. The story goes that what he really wanted to do was encourage and do something to encourage us to rapidly advance the pace of human spaceflight, and what he wanted to do was put a greenhouse on Mars and beam back video of plants growing on Mars to inspire humans to colonize the planet. And when he went shopping for a rocket, he was astounded by how much rockets cost and thought there wasn't a good economic reason for that, and that led to him creating SpaceX. And the goal of the company is to make human civilization multiplanetary. And to do that, he wants to create revolutionary space technologies that will enable eventually a large number of people to have a self-sustaining presence on Mars. That's really why we're here, and what we're doing is making incremental progress towards that goal. Everything we do is vetted by whether or not it enables us to get further towards accomplishing that goal. We're getting close to 4,000 employees. Most of them are based here in Hawthorne, although we have different other sites scattered throughout the country. So go on to slide number 3. Some more details about the company from a business perspective. We've been profitable. We've been in the black for the past 4 years. We've got over $3 billion in a backlog in terms of a backlog in our manifest, and we've had $5 billion in orders up till now. We actually, by manifest, we have the majority of our missions are actually commercial launches of satellites. As far as dollar value, the U.S. government is definitely our biggest customer. But as far as the manifest goes, the majority of our missions, 65% of them, are to launch commercial satellites. And our customers include U.S. government, other nations, and then a lot of telecom operators and other people that want to launch satellites. And we have an open pricing policy on the website, and we do all of our production and designing and testing here in the U.S. The next slide 4, shows a snapshot of some of our facilities. The biggest ones are our Hawthorne headquarters, which is where I'm speaking to you from today. And that's really where we do all of our engineering. We do a lot of our testing, at least all of our non-reactive testing, because I get very upset when you make a lot of fire and smoke in the middle of Los Angeles. And it's also where we do our operations. Our mission control is in the same building, and it's where we do the vast majority of our production. And we're heavily, another thing that makes us different from the standard aerospace model is that we're heavily vertically integrated. So about 80% of both Falcon 9, Falcon Heavy, and Dragon are all built right here in this building. It's really pretty close to metal rolling in and rockets rolling out. There's only a few things that we still don't do ourselves. A lot of valve components we still outsource, and parachutes are examples of things that we don't do ourselves, but almost everything else, including things like flight computers and turbo pumps and all that kind of stuff. We have launch pads up at Vandenberg and at the Cape. We have 2 now, 40, which is operational, 39A, which is in development. And then we have the operational pad up at Vandenberg, and we are soon to be adding one in Brownsville, Texas.
One moment, Garrett. This is Harley. I don't know if the background noise is coming from your open mic background to whatever office building is, but somebody has an open microphone. I wonder if folks could please make sure that the phones are muted.
Thanks. Yeah, I was hearing that too.
Okay, yeah, please mute all your phones. Thanks, guys.
Well, I've got you interrupted, Garrett. This is Alvin. I just got a question. What do you got against North Dakota, Nebraska, and Connecticut? You're making a social statement about them with the light blue color on their stick.
I think it's Massachusetts, and then, as you know, I'm a big Yankees fan, so that's self-explanatory.
Thanks.
Good question, Al. So let's see. In Central Texas is the one thing I haven't mentioned yet on this map, and that's where we have a test site where we do all of our reactive testing, and we do a lot of reactive testing prior to launch. So we will test each individual engine, both of the first stage and the second stage, and then we do stage testing of both stages. So you see there a small picture of our first stage inside the tripod, and every single rocket gets stage tested and then rolled to the pad, and then we do a hot fire test where we light the engines for just about 2 seconds on the pad prior to launch, and then finally we actually hold down before release during a launch. So each engine gets fired in the first stage a minimum of 4 times before we let her go, and that's kind of the process flow. The next slide shows an overview of that Texas site. And we've got the first stage testing down in the bottom right corner of that tripod you saw in that other pictures down there. We've got individual stands for individual engines in the bottom left. We've got a big hypergolf facility in the center where we do our Draco engines, which are our RCS thrusters that we use for Dragon. And then we have finally out in the back 40 there, we got the Super Draco stand, which is our launch aboard engine for our crew vehicle. And as its name suggests, that's just a much larger version of the Draco. It's instead of putting out about 100 pounds of thrust, it puts out 17,000 pounds of thrust. And then the grasshopper pad out there in the upper left or upper center. On slide 6 shows our products: Falcon 9, Falcon Heavy, and Dragon. I think you guys all know about those already, so I'll jump to slide 7 and talk a little bit about Falcon 9. So we flew the 1.0 5 times, and this slide is a little bit out of date. We've flown the Falcon 9 6 times, so we've had 11 successful flights, and we're 11 for 11 on those. We did have one anomaly early in one of the 1.0 Falcon 9s where we did lose an engine in first stage, but managed to still get our primary payload into its intended orbit. And let's see, the 1.1 has got several upgrades from the 1.0, and a lot of those were for human rating. So the biggest example is that the 1.1 Falcon 9, which started flying back in September of last year, that one has 3 avionics strings. So you have fault tolerance in avionics. The 1.0 was single string on avionics. That's one big example, but there's other upgrades as well, and we also got a lot more performance out of it. The engines went from about 100,000 pounds of thrust to 147,000 pounds. Ignore the Monday of this week comment. That's out of date. Okay, on slide 8 gives a little more detail about Falcon 9 with Dragon on top. And some numbers there which you guys could look at about as far as how tall it is and the diameter. By the way, the reason it's so long and skinny is that we ship everything on the roads, and so if you go over 12-foot diameter, then you need a police escort, and there's all kinds of other regulations that come into play that make it much more expensive. So instead, we just built a long and skinny rocket so that we could avoid all that. Let's see what else I want to say about this slide. I think that's about all the main things you already know. And the next slide is a comparison of Falcon 9 and Falcon Heavy, both a price comparison and then also capability. You see the performance as far as payload to orbit goes up by a factor of about 4, and the price goes up by a lot less than that. So what we're hoping to do is really bring down the cost per pound to orbit with Falcon Heavy. And Falcon Heavy, the metal is being bent, the design is complete, and we're already fabricating pieces of it. Our intention is to fly it within a year off of, and the first flight will be is still, I think, intended for 39A. Okay, the next slide is just a pretty picture of our crew vehicle, which is what I've been working on. I should have prefaced all this by saying that my job here is the program lead for the crew program. So that's a partnership we have with NASA under first CCDev2, and then it progressed to CCICAP and CPC, and the intention is to as part of the Commercial Crew Program, to have an American option to replace the Soyuz as far as crew transportation for our astronauts to and from the ISS. On slide 11.
Garrett?
Yeah, sure.
This is Tom Kessler from Boeing. I'm
Tom.
back a couple slides there on slide 9. Can you comment at all on what your payload performance will be in the reusable versions of these vehicles? I see the landing legs on there. Can you comment on that, what your lift capability would be?
These numbers are for reusable. So our baseline trajectories are for reusable. Is considering reusability of the first stage. In the case of the Falcon Heavy, actually, all three, the two side boosters and the central core of the first stage. So that the performance numbers you see there, for example, to Leo, the 28991 for Falcon 9 is assuming reusable, which takes a bit of a hit with the landing legs and the fuel you have to keep in reserve for the boost back and landing burns. But it's actually a pretty small. It's a less than. I'm trying to remember the exact number, but I know it's less than a 10% performance hit.
And Garrett, just to clarify, when you say reuse, are you talking about returning to the launch site itself, whether that's the Cape or Vandenberg or Texas?
Yes, so the intention is to fly the first stage back. If not, I mean, Elon would like us to land the thing right on the pad, so all you have to do is add gas and fly it again. But it's gonna be a while before we have that kind of accuracy. So we're looking at all of our launch sites. We're looking at potential locations nearby the launch pad where we would have enough flat terrain to be able to get her back.
Excellent. Thank you very much.
Sure.
Garrett, you've got a moment for another question on this slide?
Sure.
On the top half, you're looking at price, and you say for Falcon Heavy, 85 million up to 6.4 metric tons to GTO. But on the bottom half of the slide, you're showing GTO mass as 21,200 kilograms, 21 metric tons.
Yeah, that's a good point. So the up to 6.4, I'm not sure what ties the price to that. And pricing for Falcon Heavy, we've already sold Falcon Heavies, and maybe the initial missions we're looking for a much smaller capacity. But I'll be honest with you, I really don't know why the discrepancy there and how much it would cost to get the full 21.2. I haven't been selling Falcon Heavies. That's the guys downstairs do that, so I'd have to go downstairs and ask them how much it would cost for the full. And maybe it's that price tag is probably assuming multiple payloads is my guess. So that you would have maybe you would have that would be not for the whole rocket, but to launch your 6.4 metric ton payload.
You're on the satellite market.
Yeah, that's what I'm guessing.
Okay.
But I really don't know that. Like I said, I'm speculating.
No problem.
This is Doug Plata with Syslinger 1. Gwynne Shotwell mentioned previously that with the stretching of the stages, that the performance rate was able to, the performance numbers were able to be kept the same, even though the reusable landing legs were kept. I think that's the explanation.
For the explanation for these numbers being predicated upon reusability?
Yeah, the version 1.1 was stretched, and that gave greater performance. And so by adding on the reusability, it was able to still keep within the previous number.
Yeah, you're talking about the numbers for 1.1 compared to 1.0.
Yeah.
Yes, but actually the performance benefit we got from going from 1.0 to 1.1 was, encompassed the reusability and then some, because we weren't able to throw nearly this much. These numbers are for reusability, and 1.0 was not able to throw this much to either LEO or GTO.
Correct. Okay.
Right. Sure. Okay, back to slide 11, talking about Dragon. So Dragon was designed first to deliver cargo, and that's what we've been using it for. Our Dragon version 1.0 has made several successful flights up to, let's see, let me figure it. We just did CRS-3, so we've done 4 missions now to ISS where we've dropped cargo off and brought cargo back. And in 2010, it was the first spacecraft to be launched by a private company to orbit and returned. And then in 2012, we became the first company to reach the ISS and come back. And the other thing is it's the only spacecraft currently flying that can really have significant downmass capability. You could take some stuff back in the Soyuz, but it's very limited. And all the other vehicles currently that bring cargo to ISS allow for a trash disposal, but are incapable of returning anything to the surface. There's some numbers down there about our total launch masses and return payload masses. So we can bring 6,000 up, and that is actually split between pressurized cargo inside Dragon, and also about half of that capability refers to cargo located inside the trunk, which is unpressurized. So that's why you only get 3,000 back home, twice as much up, because the trunk doesn't come home. Next slide on 12, we're talking about crew now, and like I mentioned before, this is the whole reason that the company was founded, was to carry people into orbit. I mean, we're very proud of what we've done with cargo, and not to disparage any of those accomplishments, but the company was not founded to bring, T-shirts and food and water up to space. It was founded to bring people to space. And so we're very excited about the partnership we've had with NASA over the past couple of years on working towards that goal. And on slide 13, there's a summary of what we did under CCDEV-2, and this was completed back in June of, so about 2 years ago now is when CCDEV-2, the final milestone, was completed. But during that time, we focused mostly on our launch abort system, because that was the single biggest technical delta that we needed from our cargo vehicle to the crew vehicle. And so we developed the Super Draco engine, which you see there being test-fired in our test stand in Texas. And we built the test stand for it, and we built the tank and several of the components for it. So that was really the largest piece, was coming up with that launch abort propulsion system. But we also worked on all the other things we knew we had to do, and so we made progress on a lot of crew systems. So structures, you see the original layout of the cabin interior, which hasn't really changed that much from the picture you see right there. And we started working on our ecosystem. We started working, you see there a picture of the CO2 scrubbing system, which is basically LIO. We're working on a Nafion system to do dehumidification, and we started working on that back at this time too. But we started working on a lot of other things like spacesuits and displays and controls, and doing a bunch of analyses, especially about aborts and GNC work, and building up our aero database. And so a lot of work to get started on all those things, but didn't advance up to like a PDR level for most of this stuff. But then we went on to CCI-CAP, and we've been working on that for since way back of August of 2012. So really, we're right at the 2-year mark on CCI-CAP. And you see on slide 14 the milestones that we've completed, and then below the dashed line the milestones that we still have yet to go. And 2 of those, the integrated critical design review, we ended up breaking that one milestone up into a lot of individual sub-milestones to make it more bite-sized. And we've completed, we only have 2 remaining sub-milestones of the integrated CDR, and we intend to finish those up before the end of the year. And we just completed our operation CDR last week, actually, so that was still not officially released yet, but we were just notified by NASA that we met our entry and success criteria, so that's behind us. And we have a primary structure call, which is currently underway, and we hope to complete that by the end of September. So pretty soon we'll be left with only the 2 big e-ticket items, if you will, of the whole CCI-CAP program, which are the abort tests. So we have a pad abort test planned and an in-flight abort test planned. And the pad abort test is on track for November this year. The in-flight abort test is currently scheduled for January. And the pad abort test is going to be a very flight-like Dragon and the trunk, but it's going to depart from a truss structure rather than actually sitting on top of a Falcon 9. And we're going to conduct it at our pad at Slick 40 because 39A won't be ready on time. But we'll do it at the Cape. We're going to have a crash test dummy inside and a prototype seat, so we'll get data from that for the dynamics at the crew seat. And we're going to have a very flight-like propulsion system as far as everything that goes into the abort, including the avionics, which are going to be identical to the avionics we plan for the flight vehicle. And so that covers one corner case that proves whether or not we have enough total impulse. And then the other corner case is whether or not we have enough thrust and control, and also the challenge for controllability. The greatest challenge is the in-flight abort test, which will occur not quite at max Q, very close to max Q. It's actually max drag, which is right in the transonic regime. That's where we plan to do that. And we plan to fly a modified Falcon 9 as a launch vehicle, and then have Dragon punch out right when we hit that criteria. So that's what. And then you can see everything we've done up till now. We've done a lot of other design reviews, certification plan and safety reviews, and then we did parachute, some other hardware testing. We did a parachute drop test back last December, where we took Dragon with it. The Dragon parachutes had to be completely redesigned from the cargo version because they have to be able to work in a pad abort case. So you have to be able to open them up at very low altitude, and also with some potential rate on the vehicle. And so we tested that. There you see a picture of the helicopter in Morro Bay, just north of here in California. And we had a very good test back in December.
Garrett, this is Harley. I'm looking, actually I had one slide, which I guess you're going to go to. How reusable do you plan the Dragon capsule to be? Have you made an estimate of, you understand.
Yeah, so our design goal is for Dragon to be reusable for 10 flights. But our certification goal is no reusability at all. So we're trying to not bite off too much of a certification burden by certifying for reusability. We're willing to make new ones every time for NASA, but we intend to reuse the Dragons, and our ultimate goal is for a minimum of 10 flights.
Great, thank you.
Sure. The Dragon V2, that picture on slide 15 is from the big unveil that we did a couple months back. The interesting thing about that, by the way, is that Dragon you see in that picture is not a plywood, paper mache Dragon for marketing purposes. The pieces that you're looking at are all going to be used for either our in-flight or our pad abort test or our structural qual. So the primary structure underneath those thermal protection system panels is currently in our test cell being yanked on as part of our structural qual. The outer panels that you see are the flight TPS panels, and that is SPAM, our SpaceX proprietary ablative material, which is a silica-based TPS. The white stuff that you're seeing, the black stuff is a carbon phenolic impregnated pica material, and all that was manufactured for use for the pad abort test. So you're really looking at the outside. In this picture on slide 15, you're looking at the outside of the pad abort test vehicle, and the inside of this is a structural qual test article. And on page 16, you see some details about what we plan to do with our Crew Dragon. First of all, we're capable of carrying up to 7, although we plan fewer than that for the NASA mission because of the requirements to carry out a lot of cargo with powered and unpowered. But for non-NASA missions, we plan to carry up to 7. And as I mentioned before, we have an ecosystem, and the launch escape system are 8 of those Super Draco engines. So that is quite a bit of thrust. If for a pad abort, we're estimating approximately 5 to 6 Gs for an initial acceleration coming off the pad. And rapid reusability is the goal. So it's not just reusability; it's reusability without having to do a lot of maintenance from flight to flight. really what Elon wants to do is get to as close as possible to airline-type operations. The goal is to use a rocket to get to orbit, land it, and then do, or a spacecraft in the case of Dragon, essentially fill up the tanks with fuel, do a walk around, and fly again. And so that's what we're trying to get to, and we're studying all the lessons learned from shuttle and things that made it difficult to do that type of operation, and trying to figure out how we can solve those problems. But that's a tricky nut to crack. We are designing and building our own docking adapter. It's similar to the NASA docking system, but a lot simpler, and there's a lot less. There's no, for example, no closed-loop electromechanical linear actuators. It's all spring and dampers and passive system, but it's a lot lighter, requires a lot less power, and we couldn't make our design close with the NDS, which was designed for a much wider envelope of vehicles and different requirements that we don't have. So we're designing and building our own, and Dragon has landing legs, and that's what we use to take up the final. We land on land under parachutes, and then use the Super Draco launch abort system to provide cushioning for the final touchdown. And then we have landing legs that are designed to take up any residual load and allow us to land on a variety of different surface harnesses. And then the heat shield is sized for those 10 missions, and actually it is capable of 3 times the heat flux of a nominal LEO entry. So it's actually, in its current state, it's capable of a cislunar type mission or return from the moon.
Question on the use of the Super Dracos for the final touchdown. If you have aborted, does that mean the engines are no longer available, and so you can only abort in the water? Or what happens if you do land on land after an abort?
That's correct. Well, 2 things. The plan for a nominal abort, we say that all the time, and it always makes me kind of wonder what that means, but a nominal abort is in the water. So even a pad abort is designed to get you to the water. And certainly anything that happens along the trajectory is designed to get you to the water. We do meet the DAEZ requirement, so we won't put you in the North Atlantic. We'll either drop you off by Halifax or get you over to Shannon. But all those are water landings. So anytime you have to light the Super Dracos from a abort, you end up splashing down. However, if you exceed a 3 sigma wind case and drift onto shore, the good news is that the whole landing system is designed so that it's survivable if there's no propulsive assist at all. So if you come down to chutes only with the landing legs, we anticipate no crew injury, but it will be, basically it'd be kind of like landing in a Soyuz. You'll know that you've reached the Earth.
Thanks.
Sure. And I think that's it for my slides. And I know we're only about a half hour in, so with that, I'd be happy to take any questions that you guys, anything that's on your mind.
Garrett, this is Dan Lester, FISO co-chair. Thanks very much for this. And like you say, we do have plenty of time. I think Harley has had to step out, as he said at the beginning he would. Turn it over to me. So as you said, we have plenty of time for questions. Let me just ask a quick one myself. I probably should have asked this back on your slide 5, which is about the Texas site. I'm down in Texas, so I care somewhat about this. There's been some discussion about range safety from that site and FAA compliance. If you're going to ISS, 52 degrees, if your first stage impact is, 500 miles away, that puts you over Louisiana or Yucatan in the opposite direction. Now, of course, the goal is to bring the first stage back, and so that wouldn't be a problem. But what comments can you make about that, about range safety considerations?
That's pretty easy. We do not intend to go to any higher inclinations from Brownsville. All of our crew missions we intend to launch out of 39A. So,
I see.
So really, the missions that will be going out of Brownsville will be commercial missions going to a geo orbit, in which case we'll be threading that needle between Miami and Cuba and heading out that way.
Okay, that's an easy answer. Thanks very much for that.
Sure.
Other questions for Garrett?
Yeah, Garrett, this is Tom Kessler again from Boeing. could you comment on the status of your Raptor engine development and when and how that might be applied into your vehicle product line?
Sure. So the Raptor engine is a very large LOX methane engine that we're working on as the follow-on to Falcon Heavy, the Super Heavy, if you will, although I don't think we're calling it that. And it's currently undergoing component testing at Stennis. We have a reimbursable Space Act agreement with Stennis, and they have a great facility out there capable of supporting a LOX methane engine. And so we're looking at just starting injector testing and other component testing like that. And so it's, that's pretty much where we're at with the Raptor. We're deep into the design process and just starting component testing.
David Schumann, Goddard Space Flight Center. Thank you for the wonderful presentation. I'm struck by your comment in passing about the diameter of the long, skinny rocket being limited by the need for other logistics here on the Earth. Knowing the deep concern for vertical integration, were there any original thoughts given to producing the vehicle closer to the launch site to avoid that constraint? And would that have changed the design?
Yeah, that's interesting. To be honest, all those decisions were made well before I got here. I've been with the company now for about 3.5 years, but the decision to build our manufacturing capability here in Los Angeles was made well before that, and it was really largely because there's a lot of talent here in Southern California, and there's a big aerospace industry. A lot of the original founders of the company were from this area, including Elon, and that's probably the biggest answer is that Elon lives up the road, so it's convenient. So, yeah, I mean, certainly you could. It's going to be interesting when we make the follow-on to the Falcon Heavy. I guarantee that's going to be bigger than 12. Each of those cores are going to be bigger than 12 foot in diameter. So, when we figure out where we're going to manufacture those, there might be a different answer.
Thank you very much.
Sure.
Garrett, this is Alvin again.
Yeah, Garrett, Max Henderson, how you doing? Good pitch. In terms of your Heavy, you mentioned, I think, next year. You feeling pretty comfortable with that schedule? And I don't know whether you mentioned the date next year or not for the Heavy flight.
Yeah, I haven't been tracking that too closely because the Heavy, even though it has all the same components as Falcon 9, so the nice thing about it is we could talk about certifying it for human flight someday. It's not in the short-term plan, so it really has been outside of my purview. So I'm not really. I know that's what I've been told in the hallways that we're making progress. I've seen heavy components being manufactured downstairs, and so it seems like we're on track. But I haven't stared at the Gantt chart to know how much margin we have or anything like that.
Hey, Garrett, it's Alvin one more time.
Yeah, Alvin.
Got a couple of questions that I think are related. One is, back in the old days of Mir and back in the old days of Space Station, we had Soyuz taxi flights to and from just for utilization, not connected to just delivering or returning crews. Just my ignorance of the commercial crew program, is there any such concept in the works for whatever our commercial crew vehicles are going to be out there?
So I can tell you that the requirements that were released publicly as part of the RFP for the follow-on for commercial crew, the CCT cap, is a direct. Well, I don't know if they actually specify direct or indirect handover, but a twice-a-year launch. So launching a minimum of 4 crew and rotating every 6 months. So there isn't anything specific about requiring or NASA hasn't said anything about desiring a flight rate of any greater than 2 per year.
Okay. And the second one is along those lines. Do you have like a rough order of magnitude for what those launch costs are for delivering a crew coming from the space?
Oh, I got a very fine order of magnitude.
Okay.
But that's in our TCAP proposal.
I didn't want to get too going on it. Just figure how does that compare with like the Soyuz launch costs.
Oh, it's going to be much better. I could tell you this, and we've said this publicly, that the price per seat, and this is predicated on 7 people and actually flying more than twice a year. So you can expect it to go up a little bit given what NASA is looking for. But the price per seat that we were targeting was $20 million.
Okay.
Which is, I think, what's the Soyuz up to now? 73, I think, or something.
Yeah, which tracks back what I was thinking about, just taxi emissions for utilization and what that would cost for something like that. Because I know utilization is also one of the big grails that ISS always seems to be chasing after.
Yeah, and so a couple of things. One is that we certainly have the capability to fly more often than twice a year, and the price to NASA would go down if the volume went up, so it's something we would be certainly interested in supporting, but NASA at the current time is not asking for it.
Yeah.
And the other thing is that we got 7 seats potentially. So the way I think a very easy way, without even increasing the flight rate to increase utilization, along the lines of the tax emissions you were just describing, is instead of flying 4, fly 7, and then during the direct handover period for maybe up to a 10-day period, you can have an additional 3 crew members who are not required to do any of the ISS station keeping duties, but rather you can do all kinds of things with those additional seats. Either get more experience for your flight crews, or enter into more international agreements for flight opportunities, or for ISS utilization. In my opinion, what the best thing to do with those extra seats is to fly PIs. Let's really capitalize on having a human platform for space science, by not having guys like you and me, Alvin, who are glorified technicians, but rather let's take the scientists who know what they're doing in their particular field and let them do their experiments in situ, and make the kind of real-time observations and have real-time access, and it'll be a whole different paradigm for how you design an experiment on ISS. And I think that then you could really unlock the potential for much greater return on our taxpayer investment as far as the kind of scientific advances you can make. But you can also see other things you could do with those extra seats as far as education, and there's all kinds of potential there. But I've just, I could honestly tell you that I've talked to people at NASA about this, and there doesn't seem to be the level of interest out there to pursue these types of possibilities.
All right, thanks.
Sure.
Garrett, this is Lori Cossett Marshall.
Yes, hi.
I wanted to ask about your Falcon Heavy shroud.
Okay.
Do you have any plans for putting a bigger shroud on the Falcon Heavy as compared to the Atlas or Delta shroud?
So good question. I can tell you right now that the intent is to use our existing fairing that we're using for the Falcon 9, the exact same one for the Falcon Heavy. And I haven't heard of any. I know there's a desire out there from some of our potential customers, but I haven't heard of any plans to try to make a bigger one. Now the one we have on Falcon 9 right now, I don't have the numbers in front of me, and like I said, I focus on Dragon, not the commercial missions. But the one we have right now is pretty big. I see it downstairs, and I'm not sure exactly how it compares to the existing Delta or Atlas.
Well, they've
fairings.
got shrouds about the same size, but they also have very long shrouds that allow for other kinds of more volume limited payloads. So if you increase the lift from Falcon 9 to Falcon Heavy by about a factor of 4, it just seems to me to have the same payload density, you'd also want to have a shroud that's 2 or 4 times larger. And
yeah, I can tell you that
2 times longer.
Yeah, I think that the shroud is kind of oversized for Falcon 9 and maybe a bit undersized for Falcon Heavy, but it is our intention, like a lot of the things we do, we try to use as much commonality from one vehicle to the next, and even from one stage to the next, in order to really take advantage of, we use our first and second stage they use the same propellants, the same structures, the same engines, and similarly we're trying to use the same shroud, and that's just helps with economics. But
so would it be fair to say that if a customer comes along and wants a larger shroud, you'll work on that problem then, but not worry about it till then?
I think that's a pretty fair statement at this time, yeah.
Okay, thank you very much.
Sure.
Hey, this is Ed Threed, also at Marshall. I got a question also on the Falcon Heavy. Is the central core element there the same as the first stage on the Falcon 9?
Yes.
Same diameter?
Same diameter, same propellant load, same engines. Yeah. In fact, when we build a core, there's no difference when it goes on the assembly line if it's destined to be a Falcon 9 or a Falcon Heavy.
Okay, great. How about the 2 outboard booster? Are they the same as the central core?
Yes, the plumbing is slightly different, but at least it was in the original version of our design. To be honest with you, I haven't been keeping up with it, so I'm not sure if that's changed or not.
But the plans were to have the propellant load and the same 9 engines on the outboard boosters as the central core.
Yeah, I think it's the same 9 engines, same structures. So I think it's fair to say that our intention is to produce a single core, and whether it's an outboard or a central core or a single stick for a Falcon 9, that it's as close as possible to being exactly the same configuration.
And when it flies, will the engines on the central core be throttled at a lower power level than the 2 outboard engines?
Boy, now I really don't have a good answer to that question. I'm sorry, I don't know.
Okay, well, I was. Otherwise, they're all 3 going to burn out at the same time, so I figure they may be. And the upper stage is the same too, I assume.
Yes. Yep.
Okay. Thank you.
No problem.
Hi, Doug Plata here with Sysliner One. I've got a couple questions. Will the first Falcon Heavy launch use crossfeed?
Again, that was what I was alluding to before about the plumbing, and I'll be honest with you, I really don't. That was the original design, and I'm not sure how I haven't been tracking it, so I'm not sure how that design has evolved.
Okay. Another question. Whereas the Falcon Heavy will be able to place a really substantial amount of payload at LEO, because it doesn't have a cryogenic upper stage. My understanding is its TLI and TMI numbers are not really as good as the Delta IV Heavy. Will the Raptor engine be usable for a cryogenic upper stage on the Falcon Heavy?
That's a good question, and to be honest with you, I don't know. That's certainly, I think that certainly within the realm of possibility.
Okay. Is there a way I could find out?
Probably not.
Okay, that's fine.
That's the kind of thing that's pretty far out there in terms of, and I don't think we have a solid technical answer to that yet.
Okay, thanks.
Sure.
Garrett,
are there other questions?
Garrett?
Oh, sorry, go ahead.
Oh, not at all. Garrett, this is Tom Kessler from Boeing again. We all seem to be asking about Falcon Heavy here, and you haven't even flown it yet. But getting back to that same chart, slide 9, I was reading the bold print, shall we say. The $85 million price applies up to 6.4 metric tons GTO, but down below, you're showing that number that, as the gentleman from Marshall noted, is 4 times greater at 21,200 kilograms. I presume the 21 and number and perhaps the 53, those involve expending the boosters and the core. Can you comment on that and also what those prices would be?
Yeah, unfortunately, no. Anything I would give you in terms of answer, even what I said before, is really getting into speculation. That's not. I didn't put this slide together. Okay. I can refer you to our sales guys though, if you want to ask them. They probably would be able to answer that question. They know what we've sold these, so they know what's possible and what the different configurations are.
Okay, thank you.
Sure.
Hey, Garrett, John Charles here at JSC with a question about the Dragon recovery process.
Okay.
Did I understand correctly? We're talking parachutes plus rockets for the terminal velocity reduction.
Yeah, I mean it's really the propulsive assist is really just in the final descent and landing, really within the last few seconds. Otherwise, it's parachute all the way down.
Okay, good. Thanks.
Sure.
Hey, Garrett, this is Mike Rodrigues at JSC.
Hi, Mike.
Hey, I enjoyed working with you here at JSC, and I just wanted to congratulate you on your success at SpaceX. But I have a simple question for you that's not Falcon Heavy related.
Hey.
When's your guys' IPO?
Man, you got me excited. I thought you were going to ask me a question that was going to be easy to answer, and then you asked me one that's probably harder than the Falcon Heavy question. So Elon has said publicly that he doesn't want to go public until we've actually achieved our purpose, which is getting to Mars. So I think there's no short-term plan for an IPO.
Hey, thanks, Gary. Best of luck to you.
Yeah, thank you.
Other questions for Garrett? We've had some great ones. We still have a few minutes left. We've got about 70 people on the line, so I would think that there are probably lots of good questions out there.
I've got another question. This is Laura Cossett Marshall. I guess the Inspiration Mars mission is likely not going to happen in 2018, and they're looking at 2021, I think. Are you guys looking to be their launch vehicle in 2021 with maybe even a little bit more lift capability by then?
Wow. I know there's been some discussions with them and us, but I don't think anything's progressed to the point of actual, contract negotiations or anything like that. I think most of the discussions have been informal, so I don't really have an answer to that.
Hey, Garrett, Tom Jones. What can you tell us about the Texas incident?
Hey, Tom. The Texans, the grasshopper. So, yeah, most of you guys probably saw in the news that we had a failure of one of our test articles out there last week, and the test was of our 3-engine variant of the grasshopper, and what we call our F9R dev. And it looks like we haven't completed the anomaly investigation yet. We have a team working on that, so I don't have anything official to release. But I can tell you that it certainly looks like it was basically a single point failure that existed on that test article that does not exist on the Falcon 9. We think it was a failure of a single sensor, and Falcon 9 has multiple sensors in its algorithm that it uses. So if the same failure occurred on the Falcon 9, it would not affect the performance of the or affect the mission in any way. And in fact, even if it didn't have a more robust algorithm on the Falcon 9, the fact that the Falcon 9 has 9 engines, the other 8 engines could easily overcome this issue. So we've been taking a lot of risks with the Grasshopper, and in an effort to be really aggressive and test the edges of the envelope. And so we're flying this thing in flight regimes and with ConOps that it was not designed for, all in an effort to learn. And one of those risks bit us last week, and we had this one of the single point failures failed, which we knew was a possibility. And what happened was that the failure was such that flight control could not maintain the lateral boundaries of its safety zone, and so the flight was terminated intentionally upon exceeding that lateral boundary. So that I think that's the most that we can say definitively right now.
So it was a range destruction failure, not a system failure.
Yeah, well, there was no explosive flight termination device. Instead, the flight termination sequence is a series of is basically thrust termination combined with some valves that are opened, and that caused the destructive sequence that you saw.
Right. So it wasn't a hardware failure, but a sensor failure followed by a planned sequence to destruct to avoid other damage.
That's correct.
Okay. Thanks.
Yep. It's essentially a sensor failure that led it to go outside of its allowable boundaries, which we have in place. Because there's other, it's out. There's not a whole lot out there in McGregor, but there are populated areas not too far away, and we also have our own property and infrastructure we're trying to protect. So we set a certain bound, and if we exceed that bound either laterally or vertically, then the flight computer initiates the sequence that occurred.
Other questions for Garrett? Have we run them all down? It sounds like we may have. Garrett, thank you so much for an excellent talk and so much for sharing your time, your valuable time with us. And hopefully we can have you back in a while to tell us more sometime. Would that be okay?
Yeah, that'd be okay. Hopefully, the main thing is that we're waiting to find out what happens with TCAP, and if we're fortunate enough to get that award, then I should have a lot more to talk about in the near future.
Okay, looking forward to that. To everybody else, let me just tell you that although we had downtime of a couple of weeks, mostly because of talks that had to be rescheduled at the last minute, we've got a very full schedule coming up. We've got about 6 talks. We've got 6 talks for the next 6 weeks, and then more beyond that. So by all means, tune in, and we'll look forward to seeing you all back here next week. So thank you very much, everyone.
Thank you.
Bye-bye.
A large number of people to have a self-sustaining presence on Mars. That's really why we're here, and what we're doing is making incremental progress towards that goal. Everything we do is vetted by whether or not it enables us to get further towards accomplishing that goal. We're getting close to 4,000 employees. Most of them are based here in Hawthorne, although we have different other sites scattered throughout the country. So go on to slide number 3. Some more details about the company from a business perspective. We've been profitable. We've been in the black for the past 4 years. We've got over $3 billion in a backlog in terms of a backlog in our manifest, and we've had $5 billion in orders up till now. We actually by manifest we have the majority of our missions are actually commercial launches of satellites. As far as dollar value, the U.S. government is definitely our biggest customer. But as far as the manifest goes, the majority of our missions, 65% of them, are to launch commercial satellites. And our customers include U.S. government, other nations, and then a lot of telecom operators. And at the Cape, we have 2 now, 40, which is operational, 39A, which is in development. And then we have the operational pad up at Vandenberg, and we are soon to be adding one in Brownsville, Texas.
One moment, Garrett. This is Harley. I don't know if the background noise is coming from your open mic background to whatever office building is, but somebody has an open microphone. I wonder if folks could please make sure that the phones are muted.
Thanks. Yeah, I was hearing that too.
Okay, yeah, please mute all your phones. Thanks, guys.
Well, I've got you interrupted, Garrett. This is Alvin. I just got a question. What do you got against North Dakota, Nebraska, and Connecticut? You're making a social statement about them with the light blue color on their stick.
I think it's Massachusetts, and then, as you know, I'm a big Yankees fan, so that's self-explanatory.
Thanks.
Good question, Al. So let's see. In Central Texas is the one thing I haven't mentioned yet on this map, and that's where we have a test site where we do all of our reactive testing, and we do a lot of reactive testing prior to launch. So we will test each individual engine, both of the first stage and the second stage, and then we do stage testing of both stages. So you see there a small picture of our first stage inside the tripod, and every single rocket gets stage tested and then rolled to the pad, and then we do a hot fire test where we light the engines and other people that want to launch satellites. And we have an open pricing policy on the website, and we do all of our production and designing and testing here in the U.S. The next slide 4, shows a snapshot of some of our facilities. The biggest ones are our Hawthorne headquarters, which is where I'm speaking to you from today. And that's really where we do all of our engineering. We do a lot of our testing, at least all of our non-reactive testing, because they get very upset when you make a lot of fire and smoke in the middle of Los Angeles. And it's also where we do our operations. Our mission control is in the same building, and it's where we do the vast majority of our production. And we're heavily, another thing that makes us different from the standard aerospace model is that we're heavily vertically integrated. So about 80% of both Falcon 9, Falcon Heavy, and Dragon are all built right here in this building. It's really pretty close to metal rolling in and rockets rolling out. There's only a few things that we still don't do ourselves. A lot of valve components we still outsource, and parachutes are examples of things that we don't do ourselves, but almost everything else, including things like flight computers and turbo pumps and all that kind of stuff. We have launch pads up at Vandenberg for just about 2 seconds on the pad prior to launch, and then finally we actually hold down before release during the launch. So each engine gets fired in the first stage a minimum of 4 times before we let her go, and that's kind of the process flow. The next slide shows an overview of that Texas site, and we've got the first stage testing down in the bottom right corner of that tripod you saw in that other pictures down there. We've got individual stands for individual engines in the bottom left. We've got a big hypergol facility in the center where we do our Draco engines, which are our RCS thrusters that we use for Dragon. And then we have, finally out in the back 40 there, we got the Super Draco stand, which is our launch aboard engine for our crew vehicle. And as its name suggests, that's just a much larger version of the Draco. Instead of putting out about 100 pounds of thrust, it puts out 17,000 pounds of thrust. And then the grasshopper pad out there in the upper left, or upper center. On slide 6 shows our products, Falcon 9, Falcon Heavy, and Dragon. I think you guys all know about those already, so I'll jump to slide 7 and talk a little bit about Falcon 9. So we flew the 1.0 5 times, and this. Great. Well, hello everybody. It was great to hear several familiar voices during that roll call. So this should be a really fun hour, and hopefully I'll share some information with you guys that you'll find interesting. So I'll start out going through my slides, I suppose, and if anybody has a question, feel free to jump in at any time. All I ask is that please identify yourself when you ask your question. So on slide number 2, the overview of the company. You guys probably all know this already, but we've been around since 2002. And the goal of the company, really, Elon founded the company. The story goes that what he really wanted to do was encourage and do something to encourage us to rapidly advance the pace of human spaceflight. And what he wanted to do was put a greenhouse on Mars and beam back video of plants growing on Mars to inspire humans to colonize the planet. And when he went shopping for a rocket, he was astounded by how much rockets cost and thought there wasn't a good economic reason for that, and that led to him creating SpaceX. And the goal of the company is to make human civilization multiplanetary. And to do that, he wants to create revolutionary space technologies that will enable eventually